Okay, hello everyone. I'm sorry I didn't record the lecture today. This is the additional video for partial fractions. So partial fractions. Let's start with just some example on how we are doing partial fractions. Okay. Okay. Now first, if we have a functions or a fractions, a big fractions like let's start with something simple. That is, maybe we have a constant like this, and then we just have the x squared minus 9. Okay. If we can factorize this bottom here, okay, this can be factorized to x plus 3, x minus 3, right? So I can write this, that this is composed of, composed of x plus 3 like that, and then this is composed of x minus 3, right? And the top equation should be a constant a or b. Okay, let's just write a or b. And then if we try to take this, make it together, like we have, this is just x plus 3. Let me write just x minus 3. And then we solve this, and this becomes ax minus 3 plus bx plus 3. Then we can have this, okay, we can have this 12, and then ax minus 3a plus bx plus 3b, and we can solve this, grouping all together within each element. And we can say that a plus b, because there is no x here, the left hand is without x, so a plus b is 0, and negative 3a plus 3b is 12. And we can solve this, divide by 3, this is 4. So we can have system equations that we can, maybe we need just to subtract this too. So this will be 2a minus 4, or a is minus 2. A minus 2, and b is 2. So we will have, this will be minus 2, this will be 2. And we can write down the formula becomes, or the equations becomes, let me write the positive in the front, 2x minus 3 minus 2x plus 3. Okay. So let me show you another way, or another example that is still in the partial fractions. Let me check the other questions as well. Okay, now if we have the repeated linear factors, such as, let me show you the, okay. So what is the partial fraction of this? Okay, first let's see how well we can do this this factorization. So we can factor out this too. Okay, a first way, this is actually, we can have an x squared like that, and this will be ax plus b, and then this will be plus c x plus 1. We can do that, right? But we consider this x squared is a repeated linear factors. So if we want, we can have, okay, we can have to help us evaluate in the future, we can have this as our factors, okay? And when we compute, this will be a x squared we write a x squared x plus 1 oh wait, this x, okay, sorry, and plus b this is x plus 1, okay, plus c, this is x squared, okay. Now we can solve this out. And this is x squared plus 1. So we can have b is 1, and a plus c is 1, a plus b is 0. And a, we can configure that this is -1, and c will be 2. So this will be equal -1 over x plus 1 over x squared, and then plus 2 over x plus 1. Okay. Now, however, this also can be done, this part, okay? If we want to try, we can also try that one. So we will have ax plus b, because I think it's simple enough to try. So this will be ax squared plus bx plus ax plus b plus cx squared. And this will be also a plus c x squared plus a plus b x plus b. Now from just these equations, we can see that this is actually the same, right? So our approach here is correct, right? Okay. And this is our answer. So whenever you find, if you find something and then the denominator have maybe x cubed and this is x minus 1 squared, you can have this as a x plus b x squared plus c x cubed plus d x minus 1 plus e x minus 1 squared. And it is nicely done. This 3 here is repeated linear factor for x cubed, and this is repeated linear factor of x minus 1 squared. Okay, and it is nicely separated. Okay, let's try another example. That is, I think I will find more a little bit difficult. Okay, let's try that we have 4x squared minus x minus 2 divided by x4 plus 2x cubed. Okay, first we think the denominator first. Let's try to find the factors. Then we can find that this is actually x cubed multiplied by x plus 2. Okay, now we can have this repeated factors of x cubed. Okay, we can write down a over x plus b over x squared plus c over x cubed plus d over x plus 2. Okay, now we can have this try to find a, b, c, d, and we try to combine back again this partials. We first a and then plus b x plus 2 plus c x plus 2 plus d x cubed. Okay, now we first deal with this calculation, simplify, and then group all together. A plus d x cubed plus 2a plus b for x squared, and then 2b plus c for x and plus 2. Okay, now we have wait, I think I forgot something here. Cx plus 2 plus 2c. Oh, this is plus 2c, sorry, plus 2c. Okay. So 4x squared minus x minus 2. Minus 2 is 2c, so c is negative 1. And minus x is 2b plus cx, so 2b plus c is minus 1. So b is 0. Okay, b is 0. And the 2a plus b is 4. 2a plus b is 4. B is 0, so a will be 2. Okay. And a plus d is 0. So d is a negative 2. So we can have this results as 2 over x. B is 0, so we skip b. Plus c is negative 1, so negative 1 over x cubed. And d is negative 2, so negative 2 over x plus 2. This is the answer. Okay. Okay, now let's see another example. Let's see, find out. Okay. Now another way or another example or another case is if we have this. Okay. Okay, so if we look at the denominator here, if we can factor out, this will be resulting that. Okay. And if you look this x squared plus 3, this is what we call the irreducible factors that we cannot factorize anymore. Then we just write as it is. So we write a over x plus bx plus c divided by the x squared plus 3. So if we have a quadratics on the bottom, then the top equations will be the linear equations. Okay. And don't worry, we will not have this x cubed blah 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 that we cannot factorize. Okay, we just stop at the quadratic for our study. Okay. Okay, so we can find this this a and b and c. So a is x squared plus 3 like that, and this x and bx plus c. Okay, let's calculate this. So ax squared plus 3a plus bx squared plus cx. This is equal with x minus 3. So this will be a plus b x squared plus cx plus 3a. And I think this will be easy to follow. A is -1. C is 1. So a plus b is 0. So b is 1. So we have -1 over x plus 1. This is x squared plus 3. That's the answer. Okay. Okay, let's try a little bit complicated one. Okay, now both of this is irreducible, so we can just write as it is. So this is ax plus b, this is cx plus d. Okay, let's just calculate. So ax plus b, we need to multiply with x squared plus 1, and the cx plus d need to multiply with x squared plus x plus 2. Okay, we can try to find. Okay, if my writing is too fast, you can pause the video to see the numbers that I write. Okay. Let me check. Okay. Plus 2 cx plus 2d. Okay, I think that will be okay. Now the x cubed is a plus c plus x squared is b plus d plus c. Okay, and plus x is a plus 2c plus d, and then the rest is the constant will be b plus 2d. Okay, I think I will write the c first and d to make more clear. Okay, now we can solve, take the equations from left and right. Okay, a plus c is 2, and then b or b plus c plus d is 0. A plus 2c plus d is 7, and b plus 2d is 5. Okay, what can we do now? We can, I think, solve the equations. We can write down the 1 0 1 0 2, and then or let me just use the substitutions method. Okay. or substitution or elimination. So we have this, we have this. Let's just subtract this. And this will be b plus 2d equal 5. Just plus this too. So a plus d is 7. And then we have a plus d plus 2c is 7, right? A plus d is 7, so c, 2c is 0, so c is 0, right? C is 0. A is -2 then. And because a is -2 plus 0 plus d is 0, so d is 2. So b is 5 minus 2, so it's 1. Okay, so I get all equations. Then we can write down that the a is -2, oh sorry, a is 2. I write wrong number, because c is 0, a is 2. Okay, a is 2. Then the okay, a is 2. Let me write again. A is 2. 2 plus d is 7, then d is 5. Okay. B plus 0 plus 5 is 0, so b is -5. Okay, then now this is correct. Okay, so we will have 2x cubed plus 2x plus 5. Now this is the answer. Okay, that is the additional video for the partial fraction. I hope guys can have some better understanding on how we can solve these partial fractions. If you are also students of my calculus course, we will have this partial fraction to help us integrate some fractions in the integrations. Okay, because if you would like to see here, okay, if you like to see, for example, this one here, if we have integrations here, then it will be better if we take this separately, right? It will be easier to integrate, at least. Okay, that's one application of the partial fractions. Okay, I hope you get the idea of partial fraction. If you have any question, please let me know, and try these questions by yourself. Okay, if you still think that this still confuse you a lot, let me know. Okay, that's it for this video.